Hi everyone. So today we would be discussing the another dynamic programming problem, word break. So the problem states, given a string, let's say lead code and a dictionary of words, we have to find out whether the given string can be split into the words which are given in the dictionary. So suppose this is the input string lead code, can we split it into words which are present in the dictionary? So in the dictionary we have two words, lead and code. So you can see we can split the word. This would be the first split, lead followed by the code, correct? So this would be the output. If you see another example, this is the input string and these are the words apple and pen. So we can split it again. So this is apple followed by pen, again followed by apple. So two things I want you to focus over here. First of all, the word should be the word from where we are splitting, that should be available in the dictionary. Repetition is allowed. Here it is apple, there it is apple. It is fine. Repetition is allowed. So the first condition is from where we are splitting, that substring should be available in the dictionary, and when we split it, so the remaining word is this, we take on the remaining word. So what I mean to say is, we consider, we make the first split and then followed by the remaining word, we treat it as a new string, new input string, and then we again try to split it into words, appropriate dictionary words. If we are successfully able to split everything, then only we can say our answer is true, otherwise it is false. Like this one, cats and dog. So this can be first split, cats is there, a and d can be done, but then og will remain and og is not there in the dictionary. Okay, and if we take an is not there in the dictionary, so we cannot go forward because the whole word cannot be split. So whenever you see these type of questions, especially in interview, most probably these can be solved using a try data structure. Because in so how can you recognize the problems which can be solved using try data structures? Mostly those problem involve searching some pattern or some string. So that this is one of the most favorite topics of the recruiters. So when I saw this problem, and it involves searching some words, these dictionary words in the input string, I suddenly thought that okay, let's try to solve this problem using a try data structure. So let me quickly draw how a try data structure looks like. Okay, so if you see the diagram which I've drawn over here, so what we do in a try, in each node we maintain an array, or you can take an hash map as well. Let's do it here with an array. So we maintain an array of characters starting from A up to Z. Okay, and each character tells us if each node tells us if that character is part of something, some word or not. So suppose, let's say we have a word a or we can say and, we have to draw and. Okay, so how will we draw it? A would be pointing to another structure, then n somewhere in the middle, it will be pointing to n, and then again n uh, would be pointing to another tree data structure with a d. Okay, so suppose there would be a d, so a and d, and then there is a flag in the data structure itself. We call it we can name it anything. Suppose we call it is word, and we simply mark it as true, that we have. So this is making a word. Going further, suppose we have another word in the dictionary which say nd. So instead of making another node a and dy, we simply make d would be pointing to one more tree data structure, and that would be Y, and for that node also the is word flag would be true. Okay, and if suppose these are some other words, suppose A would be making some other word like a, and then going more below like CD, something like that. So we are not marking is word true in this node. That means this node is part of some continuation of some word. Okay, let me clear this out. Okay, so my idea here is what we will do, all the dictionary words, all these words, I'll make a try out of this. Okay, a try data structure, and then given the input word, we will try to search the input word in our tree data structure. And whenever we encounter any word, suppose in the tree data structure, it is storing leet and code. Okay, whenever I'm encountering leet, okay, I'm storing it somewhere, and the further further iterations would be starting after leet. Okay, so basically we would be searching this string in the try data structure. If this string is successfully searched in the try data structure, we can return true, otherwise we will return false. So a couple of things we have to take care here while searching, that we maintain some array which tells us till till what point we have found a word. Okay, so suppose we start from searching L, then we found E, then T, so the whole word is formed. So the next iteration should start from C and not from E. Okay, so these things we have to figure out. So let us look at the coding part. So this is the tree data structure which I told you about. Simply a map or um, an array of 26 characters which represent all the 26 alphabets, and simply another variable which tells us that this is a word or not. Okay, so first of all, as I told you, we'll initialize a tree and we will build it. Okay, so here I am building a try, so I'm iterating every word in the dictionary. Okay, and initializing and starting from the root part. So this is kind of a tree. Okay, so try is sort of a tree. Okay, and we're starting from the root part to check if some existing words are there, and if existing alpha characters we can use for making the new word, we will simply initialize, we will reuse them. As I told you earlier, remember I told you that if suppose A, then again it is pointing to N, then N could be pointing to D, so this whole would be a word, this would be true, and consequently these characters would also be used if there would be uh, another word nd in the dictionary. So here, if you see here, we start from the root. Let's say we are starting from the A part for every word, and we see here, simply. So what we do, we split the word into characters, and we simply check if that character, so mm, that character minus A will give us the difference. So basically it is an array of, this is an array of 26 characters, you can say A to Z. Okay, and if this is not null, if this is null, simply place one more data structure, create one more data structure over here. Otherwise, if an existing data structure is already there, we'll simply increase the pointer. So if we want to make the current word is, let's say, and here in the first iteration we made, uh, we see the initially it was null, we created an A, incremented a pointer to next. So if we have already seen A, we'll simply increment our current pointer to the next node. It could be empty as well, otherwise we will initialize it with a new tree data structure. So it is like if A has 26 trees, so only the n1 would be pointing to a new node, Rest of all would be null. Okay. So we simply check if it is null, we initialize it with a new tree node and we move our pointer to the next node. And if the whole word is traversed, so suppose A, then N and D, if the whole word is traversed, so I would be equal to the length of the character. We'll simply mark the current node, which I was telling you, this T is, if the, so we'll mark it as true. This denotes that this node represent the end of a word. So from top up to this node, up to the current node, we have a word. Okay, so we'll do this for all the words we have in the dictionary and we'll build a try. Okay, now the second part is searching the input string into the tree. Okay, skip this part. Okay, don't look at this condition. I'll explain it why it is there. So what we'll do, we'll, for every character, we'll start searching from the top. Okay, what we will do, we'll initialize it, the inner loop from where we have left the previous part, right? I told you what we have to ensure, that we have to skip those iterations, those characters which we have already seen. So suppose if we have already seen, so once leet is found, so we have to skip E, E, T and start from C. So what this is doing, it is simply starting from, so this is the skipping part, and here I'm starting from the ith index. So basically we are checking, it is sort of inner loop which we are doing for every character. Okay, so what we are doing, so this J would be initially, it would be 0. Okay, so full string Leetcode I have to check here in this loop. Okay, so again same searching would be same. The first character I will extract, so character at J means character at the input string which I have, whether it is null or not. If it is null, it means the current string which I'm trying to search is not in my dictionary. I'll simply come out of this loop. Okay, and if I have come out of the loop, it means there we don't have to go further and we can simply return it, that okay boss, we are not seeing anything in this iteration. Maybe that word could be part of some bigger word. Okay, so we'll increase in the next iteration, we'll increase the ith index. Okay, so here in this inner loop, what so I was not very satisfied with my previous explanation, so I'll try to explain it again. Okay, in the outer loop, what we are doing, we are traversing the whole string. Okay, starting from the initial index 0 to end of the index, we will try every combination we can find. So first we'll try to incorporate the whole word. Okay, from I equal to 0 means the whole word, if the whole Leetcode is part of any dictionary word or not. Okay, we are also maintaining one array word end which is equal to the length of the word, length of the input string. So what this tells us, this tells us whether we have seen that number of characters up till now or not. This basically will help us in skipping the characters in the next iteration. We'll see. So in the first iteration, we'll take the whole word. We'll start from J equal to 0 initially and to end of the length. So if we are taking the example of Leetcode, J would be at L. Okay, it would start searching the tree. Okay, null is not there. It will increment the pointer. Okay, is the current pointer pointing to a word? No, currently it is not, because we are still at L. Current is pointing to E because we have incremented it. Okay, okay, so this would not be this would not be processed. Then in the next iteration, we would go to E, then again E, then T. Leet, in leet is a word. Okay, since if we are taking this example and leet is a word which is already stored in the dictionary, we'll hit this condition and we'll do word of jth character, we'll mark it as true. Okay, again we'll go to C, but leet C is nothing, so we'll simply run into this condition and we'll come out of this loop. Okay, now what this condition would do, I is still pointing to 0, correct? but but the inner loop, in the inner loop we have already processed characters till leet, so leet is already processed. We don't want to search again from e, we have to start from c. So leet is, or we have already searched leet and we have said boss leet is found, so we have to start searching from c, this code part. Okay, so this will help us in skipping the characters, so that we skip until the last character of the previous word is found. Okay, so I is greater than 0, yes it is, because we have done one iteration. Word of end, by default all boolean values will be false, correct? Boolean of I minus 1 false, negation of false is true, so we'll keep on skipping until, so we'll keep on skipping until we found the jth character, which would be the cth part. So cth part would be true, and word of end of true, so this would give true, true negation of true is false, and we'll start searching from cth part. So j would be pointing to the index starting from c. So that is why we are maintaining this condition, to check we don't again search those characters which we have already, which are already part of the previously searched word. Okay, another thing which it ensures is, if in the current first iteration if we don't find the word in the dictionary, simply skip it, simply skip rest of the characters. Because if the earlier, the first part is not the first character is not part of anything, we are pretty sure that the remaining will not be part of the words in the dictionary. And in the end we would be returning s dot length minus 1, the last, whether the last index we have seen is true or not. Now one thing I yes, we have seen so far or not, correct. Okay, so you can ask me why I am doing I minus 1 here and not I, because we have taken the length, the string length. It would be, let's say this length of the string is 11, and array index start from 0. So this would be, so this would be doing a so this is one character more than it. So and index is starting from 0. So this is equivalent to the previous index. That is why I am doing I minus 1. Okay, so I hope you guys understood this, and that is all from my side. Thank you.